Okay. Well, apparently the last video didn't record. I recorded this whole thing, okay, for this one little section, and it didn't record. So I'm gonna talk. I'm not even gonna solve the whole thing live for you. I'm gonna talk to you about it because I'm at my wit's end. It's 9 p.m. and I want to go home and play Destiny 2. Okay, so you're trying to figure out the magnitude and direction of the electric field created at the origin by the two charges. We have a charge Q1, which I circled in green, charge Q2, which I circled in blue, okay? This is 4 microcoulombs, this is -3 microcoulombs, okay? If this is a positive charge, then it has to create an electric field that is coming out of the charge, okay? So the electric field at the origin would be to the right, okay? This charge is negative, which means that the electric field lines are coming in towards the charge, so the electric field would be going down at the origin. You would then need to figure out the E field produced by each of the charges individually at the origin. You would use KQ over R squared. The distance from each charge from the origin is 3 meters, okay? So you plug in your K and your Q values and your R value, okay, which for both of them is 3, okay? And you plug that in, and for E1, the green charge, you would get 4,000 newtons per coulomb to the right. I messed up on E2. Instead of using blue, I used red on accident. So E2, you would then plug in, the K and then your charge Q, which is -3 times 10 to the -6 because it's microcoulombs, okay? Divided by 3 squared gives you 3,000 newtons per coulomb going down, okay? And then to figure out the net electric field, you would then need to use Pythagorean theorem, which is this right here, right? We're squaring both of them, adding them up, and then taking the root of it, and you get 5,000 newtons per coulomb. You probably don't even need to do that step, I'm just now realizing, because this is a Pythagorean triple, okay? And then this is going down and to the right. You normally would have to state the angle. You don't have to do it for this one because, well, I'm choosing not to do it because I have that thing right there, which is called a degree, okay? And I've already taken well, I didn't even take the test because I didn't even take AP Physics C in high school. It wasn't even offered to me, okay? But you're the one who's taking the test, so you would have to know how to do the angle, okay? And we do that in some other problems in this notes packet. What charge must be placed at point P in order to make the electric field at the origin 0? Well, in order to make the electric field equal or at the origin 0, right? If this is the net electric field, we needed the same field going up and to the left to cancel it out. So what charge do we need at P? Well, we can figure that out using E equals KQ over R squared, okay? To get K, right? Well, K is a constant. To get Q, well, that's what we're trying to solve. R, we would need to know that this is 4 meters in the X direction away and 3 meters up. Okay, and that's a Pythagorean triple, which gives you 5 meters in the hypotenuse, right? Which is the R that you're going to use, okay? And so then you'd plug everything in. You want the charge to give you an electric field of 5,000, okay? 5,000 newtons per coulomb, okay? And then you plug in K, you plug in your distance, which we just solved for. You would isolate Q is what you're looking for, and you should end up getting that Q is equal to 1.3888 times 10 to the -3 coulombs. Now, that doesn't tell us the sign, okay? What sign does it need to be? Well, that's going to have to be analyzed in the problem because we need it to go up and to the left, right? Okay, well, if it's positive charge, it's going to be repulsive. If it's negative charge, it's going to be attractive. So we would need a negative charge at point P to satisfy this, to get the electric field to cancel out to 0, okay? All right, if this doesn't save, I'm going to make the C in Physics C stand for crash out, okay? All right, go get them.